to do with...
The things that we just did.
So, is it worth just recapping where we were? Very quickly. I was talking about submitting jobs to the Condor cluster, and we looked at what a submission file looks like. Yeah? We tell it what universe we're going to work in. We provide effectively the executable, in this case is a Java jar. We say which class to use. I'll show you a bit more in the arguments today. With jar files, you have to say which the jar files are, so there might be a number of them, not just the one you're running, but the dependencies that it needs. They might use other jars as well. And then the output gets thrown. The sort of transaction process about getting submitted and run and then completed goes into a log file. Anything going to standard error. Do you know the difference between standard output and standard error? Or that there was one? Yeah. You used to going system.out.println. Is that fair to say? In Java? You can also go system.err.println. And that's output that goes specifically to standard error and not to the console. That's very handy when you're collecting the output from standard output and you don't want error messages mixed in amongst it. So you get to see the errors, but they don't end up in the output that you actually want to process. So this is a long-held feature of things, particularly to Unix. And then the actual standard output goes to here. So anything sent in Java to system.out.println will go into that file, and we queue one job. And I mentioned you can submit it, it runs, it comes back, and you can change the number of jobs by going Q10. And I also said that each job gets an ID, and you can use that to try and drive things. So I'll show you that again later. And that's the job we ran. Now, I showed you it in Java, Hello World in Java. So this is Hello World in C. This is what you have to do to change the submission file. The universe now becomes vanilla. The executable is called hello.out because the C compiler by default calls things .out rather than .exe or .bin or whatever, it's .out. But you can rename it whatever you like as long as that's your executable. This is saying make sure this job runs on Linux. And this is particularly important for a job like this. Any ideas why? Yeah? The compiler. We will have compiled this on one of our Linux nodes. So this executable, this hello.out, is only going to run on the types of machines it was built for. And this is my way of capturing. I'm going to build this on the pound nodes, the Linux nodes, so it'll make sure it only runs on there and I know it will work. I don't want this going on the Windows network because it will not run on those nodes. And then that's the same output you saw before. So, oh boy, fingers crossed. So here we go. We're on the Condor. This is me. I've already logged into Condor. I did it via... Actually, you won't see how I did it because I'm here. Hang on. I'll just clear this out. Ooh, okay. Sorry, I tried to configure the... what have I missed? Background is that. Pop-up is that. Let's see if that works. No, it doesn't. Oh well. What if I type? Oh, you can at least see that. Okay. I've secure shelled into this system. Let me just remind myself. So I am going to go into... What is going on with this? Is this on... So the background is that. Text is that. That should be fine. I don't know what it's done. I'll not type clear again. So in here I've got my different versions. So I'm going to go to hello.c. So in hello.c I have the actual executable. This is the text file containing this very complicated hello world. I've compiled it into... This is really not very easy at all, is it? I've compiled it into hello.out, and here I have my submission file. So I can say more sub. I'll hit the tab key. That's sure to complete, and we can see the contents of... I'm sorry, this is a bit of a mess. I don't know quite why that's not showing the background the way I want. Oh, good. We're back to normality. Let's have a look. Clear obviously fills it with a null character or something like that. There's something weird going on. Anyway, I will now submit this. So we go Condor _ submit hello dot, and then it's sub. It's the text file. It's submitted. Oh, dang. Oh, I missed it. Okay, hang on. Let's do it again. Ah, got it idle. Oh, it's still idle now. It's still idle. Now, see, first time round, it ran before I could even get to it, and now it's, let's have a look. I'm just checking the queue for me, and it's finished. And if we look here, we've now got out.error, which I think will have nothing in it, I would hope, because nothing went wrong. The log file should tell us about the last submission, so there we go, did it work? What? And I have no idea why this is changing colour. I think it's just out to get me. And we want to see the very exciting output, which would be in hello. No, hang on. It was out.txt I said, wasn't it? Hello world. There you go. So that's it in C. It doesn't normally look black and white like that, but that's just weird. I don't know what's going on. Right, so let's go back up here and go to the Python version. Is it useful to see Java, see Python, see the equivalent, what's changing? I'll try to be quick. Obviously, here you go. Here's Python's version, succinct as always. This is only going to work if you're using it on the Linux system that's where Python lives. That's the path to the Python interpreter. On Windows it doesn't work quite like that. But there we go. And the submission file is very similar. It's vanilla again. The executable this time is our Python script, hello.py. Output where it went to before, run it on Linux.
Even Python is built in Linux and can run on Linux?
No, this could actually run, okay, this could run on any of the machines except for the fact that I've specified the path to the Python interpreter in my script, and that path is only true for the Linux machines. If I didn't include that, then I'd have to have some other way of running the Python script, or Windows would have to be configured to see a Python script and run it. Yep?
Basically, you have to give them the file path where the Python interpreter sits on the system.
It either has to have the association for the Python script, or you have to provide the path, and I'm providing the path. I'm also doing it because it's nice when I'm not running on Condor, I can just run the script full stop without having to say Python script name. I can just run it like this. So that's the Python thing, and I haven't run this one in a little while, but I shouldn't say that, I should just say, yeah, this is how it works. But I've been tripped up enough times. So I'm really sorry, I'm always tempted to log out of this. I think I will after. Oh, we're in here already, aren't we? So I will do Condor submit sub. So this is me submitting that Python script. It's gone in. Condor Q deck. That's my username. It's already finished. And out.txt. There's the output, which wasn't there before. You'll notice. So it's gone to the nodes, gone and run, and come straight back pretty quickly. This isn't meant to be hard. I just wanted you to see the consistency of it. Right. Next thing. Excuse me a minute. Right. Let's try that again. Now that's interesting. Why is it? Okay. I'm not going to ask any questions. Is that still perfectly readable for you? Yep. Okay. So this is how I logged it. Oh, it's forgotten my SSH. Will it do? No, it won't. It's not. Okay, I went SSH minus P541. My username. So if you've got SSH on any of your machines, you can do this. Your username at pound.cs. And you can do this remotely. You don't have to be here to do it. It says, do you really trust that? I go, sure. Right, I'm logged in. So I just wanted to get this font right. So, and we've been looking at We were looking at the hello examples. So I went Condor Q before, deck, that gave me the Q for deck, and there's nothing there. I can actually omit that, and I've no idea what's on here. Sandy was running stuff last time. Oh, yep, Sandy's still there. This tells me what other people are doing. You can put their initials in and find out what they're up to. Is this going to work any better? I don't think it is. He's got 24 jobs running, and they've been running for quite a while. But you can find out how busy the system is, not just yourself. So I'll go through a few more examples of that. Right. It's probably easy to show you on here for now. Here's some jobs I submitted a while ago. And this is what you would see if my job was running. We talked a bit about this before. You get the job number, so that's the numbers before the dot. So when you go Condor submit something, that's a job, and then within it there are the individual sub-processes. So there's 1517, etc. You can cancel a specific job by going Condor underscore RM and then the complete number, or you can cancel the whole job by just giving, say for example, 7659. We find out who it belongs to, when it went in, how long it's been running for. So this one was running for 18 hours, 12 minutes, 17 seconds when I looked. And it's running. You'll see here below, it was one of a set of 8 jobs that I was running. None of them were idle, which meant they'd all gone on. We caught my one moment ago being idle, I think, didn't we? It was sitting idle. Mean it hasn't gone on to the cluster yet. Running obviously means it's running. Held, you don't want to see any jobs held. If you see a job's being held, it meant it's tried to run and it's not worked. So if it's held, have a look at your log file, your error file, see if you can see what the problem was, but remove it and try change things and run it again. The held means it's been held back because it didn't work. And also beware that things can sit idle sometimes for 5 or 10 minutes. And when we were setting the system up, that was infuriating because we weren't sure if we got it right or not, and we had to wait 15 minutes to find out if we had got it right. Yeah? So you'd configure the configuration file, which is extensive, try and get your thing to run, and then you'd have to wait 15 minutes per attempt, like changing a letter or a number, to see if it had actually done the right thing. But you don't have to worry about that. You're not doing anything. Another thing you can do is Condor status, if you just want to find out what's going on in terms of availability. So you go Condor underscore status, and that will tell you about the complete cluster. And what you'll get is a list of each node available on the cluster and what it's doing, along with a summary at the bottom. So today there are 790 cores available, of which 259 are busy doing stuff. Now they're being used by other people. The Condor cluster is actually using 24 of them, and there are 508 nodes free to do something with. So these are board computers that would like you to entertain them. Yeah, at your fingertips. That's a lot of processing effort, isn't it? Except for cryptocurrencies, please, as I said the other day. None of these are running graphics cores anyway, and you'd be better off using graphics cores. And you can see the breakdown between Linux and Windows. We have a small dedicated cluster of Linux nodes. Most of our cores are actually Windows Lab. They're actually Windows Lab nodes. So actually, we could do an experiment. Is that when you go back, obviously between the 4 o'clock, the end of this lecture and the 5 o'clock lecture, you'll do lots of hard work, and the number of nodes here should drop. And then you could come back. No, let's not do that. You believe me, don't you? So. Any questions on that? We're good? Right. Let's go down. I've talked about this bit before and that bit. So you get the idea that now you can queue an arbitrary number of jobs. So be careful how many you type. And that each job has got a process number. And we'll come back to that again. So if you run a job, say you queue a job 10 times, you then get, and they all print output to standard output, you'll get 10 files, and then you'll need to collect all that information and analyze the output of the separate jobs. What does this feel like? in terms of processing computing, not whether you're bored or not. What does that feel? Does that feel familiar?
Reduce.
You're reducing, aren't you? And you actually you can write another Condor job if you like to do the reduce, or you can do it on your own. If you've been very careful about how you structured your output, so say, for example, each process just produces one line, tab separated, and then you've got 100 jobs you run, then you've got 100 lines with tabs between each column, or commas between each column, and then you just want to stick them all together. Does that sound like something you would do? I hope so. Everyone's looking a little dazed and stunned. It's been a hard semester. I shouldn't have really asked that, should I? I know it's tough. Sorry. Thank you for being here. So, actually, what you can do, certainly in Unix, there's a rather nice, actually I'll show you in here first. There's a rather nice feature of the cat command. You can concatenate files together very easily in Unix. So if you've been quite careful about it, you can go to the directory that's got all your files, and you can say cat, for short for concatenate, some pattern, and then redirect the output of that into another file name. So what this will do is all files that start with out, have an arbitrary number of characters, and end in .txt, will all be glued together, and the result of that shoved in here. It doesn't actually glue the files together, they stay where they are, you don't harm them in any way. I was going to make a really bad joke there, I'm glad it didn't. And the contents of that end up in combine.txt. So is that available on Windows PowerShell now, or not? Anybody got Windows 10 with PowerShell on it? No? Nobody here? Can you see if cat's available on it? Well, just as a curiosity. Anyway, while I've distracted you doing that, we can at least go into here. So here's the hello thing we did, and if I behave myself, we went to hello dot. So here's the Java version. If I remember rightly, we ran this 10 times, didn't we, that Java thing? I put Q10. So we've got a bunch of files here with really exciting stuff in them, like hello-3. See, that's got hello world in it, and I want to see what all the other 9 files have got, and I would like to put them all into one file. So I can go cat, oops, hello dash, right, here's another one. Star is an arbitrary sequence of characters, question mark is an arbitrary character. So that will just catch the number .txt. And I'll put it into hellos.txt. So now if I go what's in, oops, give it an extra, hellos.txt, I get the sum of the output. So that's your reduce step. That was quite nice, wasn't it? Really useful. And you can use all sorts of filters. Obviously it's pretty pointless having 10 lines saying hello world, but we'll get there. It's very quick. So that's your reduce. Is that quicker than writing a reduce step for MapReduce? There we go, I'm winning now. Okay. It does, well, there is one constraint. It does require you to think about what you print to standard output, to make sure that that's in a nice format that'll just line up in equal columns. But that's not hard to do, so you just have to think ahead very slightly. Right. Next thing. Passing a bit more information in. I mentioned before that we've got this $process macro variable that we can use, and we used it to change the name of the standard output file. Yeah? We can also pass it into our program when it's running. So we can have arguments here, for example, we can have hello being the class to use and $process being a number that's passed to that class as a command line argument. Have you done command line arguments? How many people have done command line arguments? Only a couple of you. Right, this is a way to pass stuff in to code. Let's have a look. You've seen code like public static void main string args, yes? And you thought, don't like that, we'll just ignore that and get on with what I want to do. Perfectly rational response. Well, it turns out, you think, what is that? And I'm just ignoring it. That is the string, it's an array of the things that the outside world is trying to pass into you, in case it's of any use to you. So in this case, that is something I want to pass in. It's a number. It comes in here as a string representation of that number. If I pass 3 things in, this would be an array with 3 things in it. As it is, I'm only passing in, if that's my class, I'm passing 1 extra thing in it. Yeah? So in here will be my command line arguments. Does that follow? Not so bad now? This empowers you. It does, honest. It's really useful. Okay, it helps. Empower sounds so good. Right, so here I come. I've got my program. This is a little bit of code we wrote just to try and figure out which nodes were and weren't responding in our Condor cluster by getting them to print their IP address out that the job ran on and finish. But it was quite useful to find out which job it was that ran on which machine. Or in our case, didn't. We had a bunch of nodes that were saying, yep, we're here, but nothing ever ran on them, and this was a way to find out. So here I created an instance of my node object, and I say, right, how many arguments have I got? As long as I've got at least 1, i.e. something has been supplied here, then set the task ID to be the integer equivalent of whatever that string is. So arg0 is the very first entry in that array. Am I going at reasonable speed? I don't want... Okay, fine. So I take a note of the task ID and then I run. And then what happens is, well, you don't really have to follow this very much. This is just trying to get the IP address of the machine it's running on. And if it gets it, or gets at least one of them, this actually gets the set of them, it will print out the node ID that I just set along with the IP information for it. Yeah? But this allows me to pass information into this very job, telling it which Condor sub-process you were. I don't tend to use it like this. What I actually tend to do is take a look at that number and actually decide what to do. So one of the problems I'm going to look at later on is travelling salesman problem. Hey, it's actually very core to the research we've been doing for quite a while now, or a variant on it. And what we were trying to do is find out how well our algorithm responded to a different problem. So we had 50 different problems of the same type to solve for each case we were doing. So what do you think I used the task ID, the thing I'm passing in, to decide? Which problem you had. If you were running this, you were doing a travelling salesman problem, it told you which of the 50 problems, so we ran 50 jobs at a time, saying if you're 3, you have problem number 3, if you're 7, you have problem number 7. I mean, I could run it over and over again, and each time, each job just ran the same relevant problem. So that was useful to me. You can use it any way you like. So when I run this, I now have an extra thing in the arguments field telling me which process to run. And I'm not even going to show you the output of that because I think you seem like you need coffee, chocolate, anything. Not alcohol. I think that would not be good. It might briefly be good and then go downhill fast. So, next thing is, how are we doing? Is reading and writing data. So, let me think about this. Quite often the job you're running needs to read data in from some file somewhere, yep, do some analysis of it, and then pump results out to standard out. So we must have a way of saying what input files we want to use, and then picking up the stuff to throw out. Now, it used to be, and you should feel very grateful for this, obviously you won't do, but it used to be that there was a Condor command called transfer input underscore files equals, and then you had to provide a long list of every single file you used that was going to be read. Basically, every single file that needed to be sent to the node. And you're thinking, well, that's all right, I've only got 3 files, that's no big deal. But you can imagine situations where you've got 50 or 60 files. You'd literally have to sit there and type them all out. This was tedious. In fact, I think at one point I had to write a program to write that file because it got so tedious to write it by hand. I would basically get it to look in a directory, read the contents and write that as a string so that I could then copy it and put it into the... Anyway, we don't have to do that anymore. Afterwards, you should also say, if you're going to transfer files, now what you can do is you can have a directory in your submission directory, say called resources, and in there you can put all the files you want to transfer over to the node when it runs, to the job. But be very careful, when it runs on the node, those files will not be regarded as being in a resources directory. Yeah, they'll be regarded as being in the directory that your job is running in. There's no subdirectories whatsoever. So when you refer to them, you wouldn't go resources/input-data.txt, you would just go, it's in the path input-data.txt because it's right there with me. So don't get caught out by that. There are no subdirectories.
What directory are you actually running in? Does it matter what directory you directly
You've no, yeah, you should basically you've no idea where you're running, and you shouldn't assume anything about where you're running. You're certainly not allowed to look around about where you're running. You're basically in your own little enclave, and you're locked in, and just don't, yeah. But yeah, if you start looking out, you'll get prodded by the system and get back in there. Yeah. Just assume that you're in somewhere mysterious, your own little sandpit, and you have no directory structure, and everything's running local to you. And everything you produce cannot be written to subdirectories or anything like that. It just gets dumped into the directory you're in. This is done for sort of security reasons partly. I mean, it would be nice to be able to have some form of subdirectory. Anyway, the way it works, it doesn't allow that. You also must remember to put this in. This caught us out. Once, you'd think this is obvious, but you have to tell it, yes, you want to transfer files, and yes, when you're done, can I have them back, please? What is nice is you don't have to specify the output files that you're going to produce. It just takes a note of all the things that appeared when your program ran and just copies them all back to you. So that's handy. You don't have to give a big long list to that. So that's the sort of full set. You can say, here's the stuff that my program needs, transfer everything in there across. When you're done, give me, when this program completes, give me everything back. Any questions so far? No questions at all. We're all happy. I've talked about that one. So, right. I think I've got enough time to talk about DAGs, and then we'll talk about, in the next lecture, I'm going to give you an example of processing data, and what the example will contain will be things like hash maps and so on, and how I use hash maps, which I think might be relevant to what you're doing, just a bit. In fact, I have a suspicion that my example is quite closely related to what you're doing in your assignment, having had a chat with Kev. It's not your assignment, as far as I know, but at least to show you how I use them, and I'm going to basically provide you lots of source code and walk through it. Is that helpful? Okay. And you can ask questions, and I'll not obfuscate. But before I get there, I want to show you one more thing about the Condor structure, which is very handy. Because the moment we've just talked about running one type of job repeatedly, but actually Condor's a heck of a lot more flexible than that. What you can actually do are run lots of different jobs in a process hierarchy or structure, and say run this lot, well run this, which creates data, which then run these jobs, and then collate some of it and run those jobs, and then collate more jobs. Yeah, you can create this whole network of jobs. I'm not going to ask you to do that. I shouldn't have said that. I'm going to ask you to do this lots, so you'll listen to me. No, I'm not. I'm just showing you that it's possible. What you're not allowed to do, however, is go back on yourself. You're not allowed to introduce a loop. So we call these things directed acyclic graphs. It's a really fancy name for no loops, please, I think. Yeah? Have you heard of DAGs before? Directed acyclic? Yeah. It's just basically saying, oh, it's a graph, it's a network structure, but you mustn't loop back on yourself because it will never terminate. Here's the world's simplest DAG. Well, actually, I suppose one node alone is the simplest. But it is a structure, say, run job A followed by job B, but only when job A is finished. And this is how you specify it. And you create a text file. That's all this is. You give a job a symbol, so A corresponds to the A there, and then you have a submission file associated with it. B has, in this case, the same submission file. Then you give a relationship between your nodes, so A is the parent, B is the child. And then you can give, you can set up variables, so you can set strings, for example, or parameters that get passed to the different jobs. So for job A, I have a message, it is a weekday, and for job B, I have a different message which says I prefer weekends. So this message variable will be passed to both these jobs and do different things. What's quite nice, well, okay, so here's my actual submission file, and here is that variable I sent. So the message can be anything you like. That can say cloud, if you like, or I don't know, cat or elephant. It doesn't really matter what it's called. Whatever you call this here, so if that says elephant there, you put elephant there. Just so you know that message is not something special. It's just whatever variable you like. That gets substituted and the job gets run. More complex case. This is much more normal. What does this look like? MapReduce. Yeah. Take some data, split it up, send it off to these jobs, merge the results. So that's your MapReduce structure in Condor. And not just Condor, you get the same idea in your other cluster programming environments. So you specify each of the jobs. The split job is one thing. You can see that P1, P2, P3 are all variants of the process submission job. And these are all these text submission files that we were looking at before, like universe equals vanilla, executable equals this. That's what's in these. I've got my merge job, which is a separate submission file, and then I say the relationship. So split is the parent of P1, P2, and P3, and merge is the P1, P2, and P3 are the parent of merge. And then we can pass different bits of information in. So you could see here for perhaps split creates 3 files, data 1, data 2, and data 3. These are passed into P1, P2, P3 processed, and then the output of that is used by merge to do something. That's exactly what you were doing in MapReduce. But the difference, in a way, is MapReduce just does that one thing, doesn't it? That's all it does. Can you see with this setup I can create any structure I feel like? I can make a much more complex thing. The point about MapReduce is it tackles a specific problem, whereas this is a much more general purpose tool. In all likelihood, you're probably more likely to use a cluster programming environment like this than you are to use a dedicated big data Hadoop type cluster. Because there are far fewer problems of the scale of big data than there are like this. This is much more traditional and has been done for decades. MapReduce to use in a Hadoop environment efficiently requires you to have a very large data set. Otherwise it's just not worth the effort. One other final thing to note is that these jobs do not have to be remotely the same programming environment. So split could be written in Python. This could be written in C, and merge could be written in Java. And as long as you just provide, producing text file, text output, text input, we don't care. You can get a team, one team to write this, another team to write that, and another team to write that. And as long as you agree what the file input output is, it doesn't matter. Am I able to sell this to you in any way at all? Is it? It's late in the afternoon. I'm just hoping you see that this is extremely flexible. So, yes, it looks clunky, but Hadoop's designed to do one thing and do it extremely well. This is designed to do many, many things, and you have to think about it a bit better, but it's a heck of a lot more flexible. Right, I think I'll stop there. Well, I've run out of lecture now. And I'll see you in an hour, hopefully, some of you, where I will go through more complicated examples. And I too will have a cup of tea and some chocolate.
When are you doing the hash function?
I think I'm going to start doing it at the next lecture.